Hi, here I am talking a little bit about vectors today, some more vector applications. We're in chapter 8.3. We are looking at vector applications once again, and we're going to concentrate right now on number 6 from the book, page 269. A plane is flying on a bearing of 170 degrees at a speed of 840 kilometers per hour. The wind is blowing in the direction north 120 degrees east with a strength of 60 kilometers per hour. Well, first thing we have to do is understand what a bearing is. Bearings are different from regular trig angles. Bearings take off from 0 degrees, which is north, and work their way around clockwise to 90, 180, 270. So when we talk about 170 degree bearing, we're really looking at 90 plus another, this would be 180, so just off here. So I have another drawing to help you with that. But keep that in mind when we're dealing with bearings. All right, here's what the picture looks like. We have the plane here is at a bearing of 170 degrees. So we're coming out this way with 840 kilometer per hour. Okay. Now our trig angle that we're going to use is actually negative 80. All right, so trig angle is negative 80 because in this case it would be 0. We're going to go down negative 80 degrees to get to 170. So we'll need to work on that. The next thing is that the wind here in green is blowing at north 120 east. Well, that means 120 degrees east of north. So 120 degrees east of north, okay? At 60 kilometers per hour, our trig angle here that we're going to be looking at is, if it's 120, this would be 90, so negative 30 degrees is our trig angle that we're going to use in our calculators, okay? So let's go on to where we're looking at some calculations. Now, we have Part A, it says, find the vector components for the plane and the wind. All right, so let's do the plane first. The vector P for plane, 840 is what we had as a flight. Cosine of negative 80 degrees in the I direction or in the X direction, plus sine of negative 80 degrees in the J direction. Well, cosine's an even function, so that means it's going to take the negative out, and it would be cosine of 80. Now, sine is an odd function, so it will take the negative and push it to the outside. So that's how we get the negative 840 sine of 80 degrees. So those are the component forms for the plane. Now, let's look at the component form for the wind. 60 is what it was flying at, 60 kilometers per hour, times the cosine of negative 30 in the I direction, and sine of negative 30 in the J direction. Once again, we have an even and odd function, so we have 60 cosine of 30, comma, negative 60 sine of 30. So there's your component form for the wind and the plane. Next thing, part B says, hey, find the plane's true velocity. Well, if we want to find the true velocity, what we have to do is we have to go back and figure, well, if a plane is moving at 840 and this wind is coming this way, so I have a plane flying and I also have a bit of a tailwind, so it's moving a little bit faster. Okay, that tailwind is actually helping it out some. So what we have to do is we have to add the x comparison, or add the x components up, and then we add the y components. So if I take 840 cosine of 80, and I add that to 60 cosine 30, I get 197.83 in the x direction, and negative 840 sine of 80 and negative 60 sine of 30 in the y direction. I add those together, and then calculate that out. You get negative 857.24 as your plane's true velocity in the direction that it's going. All right. Well, velocity is different than speed, right? So speed is what we're going to look at next. This one says, hey, find the true speed and direction of the plane. Well, speed and velocity are different. So in order to find speed, what we do is we take the magnitude of our vector components. So we're going to take the magnitude of those. So S for speed is the square root of the x direction squared plus the y direction squared. And when you do that, you get 879.77 kilometers per hour, which is good because we expect it to be a little higher than the 840 that was originally said because they do have that 60 kilometer tailwind, all right? To find theta, or the angle that it's traveling in, is we take the inverse tangent of the y component over the x component. And when you do that, you get the theta of equal to negative 77 degrees, all right? Which makes sense from our picture over here, right? We would come down, if we came down this vector here, we would see that it's about negative 77 degrees. We could figure that out, which we've done. And now, but we want to know the bearing. So the bearing then, because it goes from 0, now we need to take that negative 77 into account and actually add it to the 90. And so when we do that, we get 90 plus 77 degrees is a bearing of 167 degrees. All right. Thanks a lot. Have a great day. Hope that helped.